governs this, and deploys the versions of the trusted firmware. Next, on the device development side, we've been working on a number of different things. So when you think about the software that runs on these devices, today in the world of MCUs, the types of devices are highly fragmented, as I said earlier. And then from an embedded software perspective, there's no one solution. So like in mobile phones or in PCs, we do have a consistent software environment. In the case of mobile phones, we have Android and we have iOS. PCs, we have Windows, we have Linux, and so on. So with MCUs or Cortex-M based devices, such a thing doesn't exist. And so at ARM, we've been working on something called Mbed OS, which hopefully some of you have heard about. And Mbed OS, I'll talk about that in the next slide, is a way in which we think we can enable developers to take a software environment, use that as a foundation, and then create their application, right? Their device running the software. And so we've made it easy from multiple perspectives, right? It comes with a tooling environment, it comes with different connectivity stacks, it comes with common support for networking, TLS, and so on. All of these are common things that you need regardless of what your device is doing. And so we felt we need to really make it easy for that to happen. In parallel with that, we've been working on hardware support because the types of devices, the number of boards, the number of hardware platforms is enormous. And if we can get those Mbed enabled or certified, then it means it gives you as a developer confidence that if you use this hardware with this version of software, it'll work together. And then finally, Mbed OS is an open governance project. So again, while ARM is taking a lot of the heavy load, we've made sure that we're doing this in the open environment. And you can see some of the statistics over here on the slide in terms of number of people that are engaged with it, how many developers are using it, the number of components. You know, some of the stats just over the last 14 days you can see in the middle box at the bottom. And so for me, Mbed OS is a way in which we can start to defragment the environment, right? Ultimately, I do believe that for IoT to scale, 1, 2, 3, maybe no more, operating systems will need to emerge in this space. Because if they don't emerge, I don't see a way in which we can scale IoT faster. And of course, IoT will happen, will be painful. And we can't trust the security of the devices if it's not built on a common foundation. And by that common foundation, I mean PSA, I mean trusted firmware, I mean the OS that runs on it, I mean the certification that you need to do on that as well. So all of that has to come together. And Mbed OS is a way in which we believe we could scale this out. The other thing we're doing is we're seeing that a lot of the developers are experimenting with different types of environments. So initially, they might start with something like Arduino. They might have other choices of maker environments in which they're experimenting. And these are not just makers in the traditional sense. These are actually developers inside companies who are starting with Arduino to do their projects, to do their experiments, and then using that to then do their scale out in the future. So we've been working very closely with Arduino to get their platforms to be Mbed enabled. And that way, if a developer starts in the Arduino environment and carries on, eventually when they want to go to scale and production, Arduino doesn't let them do that. They can start moving over to some of the work that we are doing on the cloud side, because that gives them a scalable environment in which to deploy their IoT devices. On the data side, the other open source project that we've got is called FluentD / FluentBit. So these are effectively the same data collection pieces of code that are client-server compatible. And the problem they're trying to solve is how do we make it easy for data from different sources to come together into a common place and then be sent in a batch mode up into the cloud, rather than every single source trying to send their pieces of data individually up into the cloud, which is quite inefficient. So this is an open source project that is actually the number 3 project on the Cloud Native Foundation. And this is quite good, in terms of this makes us really happy, because this is a very widely supported activity that makes it easy for data from any source to be collected and then sent up into the service that we are offering. And that service is really just an endpoint that data can go into, and then eventually you can start doing the ML, doing the analysis, maybe writing some applications, visualization. And for that, our cloud service has all the different integrations, both on the source side as well as on the sync side, for you to take advantage of the data. And then finally, I talked about the different challenges with the things that you need to do on the cloud. Right? You've got device management. You might want to manage your connectivity because you've got cellular connectivity. You might have a device that gets connected in Japan, or you might have a device that gets connected in the US, but you want to have a common connectivity solution for that. So we are offering different components in the cloud service, as you can see on this slide, which are really there as foundational services for anybody to use to start getting their devices connected and then starting to use the data from that point on. And the services are designed to be composable. So if you only wanted one of those services, you can do that. If you wanted all the services, you can do that. If you wanted the service on-prem, which is actually the case with our device management service, we are seeing a lot of customers saying, I want it on-prem, but I also want it in the cloud, that hybrid environment. So that's also available. And so this diversity of choice, we think, is going to be really important for customers to start adopting IoT for a variety of reasons. From in some cases, the data cannot go outside the country because of regulatory requirements. So we believe that for IoT to scale, services like these will need to be available in different regions. We need to be available in different hybrid environments as well. And then finally, my sort of summary of all this is, this is a big, complex topic. I do believe that for IoT to scale, not only in terms of the solutions, but the types of software that we're going to have to deploy, that will need to be done in conjunction with people like yourselves in the open source community. So from a trusted firmware, we're already doing that. I'd be quite interested in understanding and what you see and what you're thinking. But also the question that I'm asking is, what else can we do? Right? We're starting to do some of the embedded software work with EmbedOS in the open community. What else can we do? How can we take this further? How can we work together to scale this faster? So that's all I have. Thank you, everyone. I don't know if we have time for questions, but I didn't do a time check.
Yeah, we should probably
wrap up. OK, so that's all. Thank you, everyone.
I'm pleased to introduce our next speaker, Ed Nightingale, Director of Engineering at the Azure Sphere team at Microsoft. After the keynote, Ed and Brian Fairfax will stay in this room and will provide 2 technical drill-down sessions on the details of the optimizations and innovations that Microsoft is applying to the Linux kernel and security. And you will be impressed by the maturity of the approach. Welcome. Thank you, Ed.
Thank you very much. Hi, everyone. My name is Ed Nightingale. I'm the Director of Engineering for Azure Sphere. It's a pleasure to be here today. And today I'm going to be, in this first talk, diving in a little bit into the principles that lie behind Azure Sphere, why we're building this product and what our goals are. So Azure Sphere is a business focused around microcontrollers. It's the low-cost, single-chip computers that we're all familiar in talking about inside of IoT. And there are about 9 billion new MCU devices that are built and deployed every single year. The thing about microcontrollers is they're really the fabric of computing in our everyday lives. They're the computers you never notice, right? If you have a screen, if you have a device with a button, it probably has an MCU inside of it. They're in your homes, your hotel room, and in your offices. And historically, the way I think about MCU development is that it's fire and forget. You build an MCU to do one thing. It runs a clock on a VCR, it runs a motor, and it does nothing else. And that's what it does for the lifetime of the device. And you write that software once, it works in a constrained environment, you never have to worry about it again. But the sea change we're seeing, and I think that many of us are focused on in our mind, is connectivity. This is 2014, where you had an MCU with an on-die radio. And this is the big change that we're all thinking about. I think this chip at the time was $2.50. And when you can connect anything to the internet for less than a cup of coffee, the question is, why wouldn't you? And so this is leading to a huge sea change. And the fundamental thing I want to keep in mind as you think about this change, and we'll get into the motivation a little bit more in a second, is that when you take a single purpose fire and forget computer and connect it to the internet, it suddenly has the potential and capability to be a general purpose computer capable of doing anything an attacker wants it to do. And so that is the change in thought and the change in thinking that's led to a lot of the development inside of Azure Sphere. Now, there's still occasionally get questions about why would you want to connect a device to the internet. This is the simplest example, the one I always come back to. You wake up in the morning and you come downstairs and ice cream is all over the floor because the compressor stopped working in your refrigerator or your freezer. And that leads to an unhappy family, it leads to unhappy kids, at least in my household. An alternative is that you wake up and you have a phone call from the person company that built your refrigerator. And they say, look, we see that your compressor is about to fail. We have someone who's in the neighborhood. Would it be okay if we came by and replaced it? Fundamentally, a different experience that is made possible through connectivity, a very simple one that leads to better brand loyalty, to a better experience with your devices, and in general, less melted ice cream. So this connectivity is really all about the democratization of IoT. It enables IoT devices to have a digital feedback loop, to connect customers, operations, and products and assets. It also allows brands that typically lost their customer relationship at a store to continue that relationship long after the product is bought, which changes the way companies think about selling their products and really think of having an ongoing relationship with the devices they interact with. It also empowers employers and employees to really better understand the products that they've built. So the opportunity. So at the National Retailer Federation in January, we announced a partnership with Starbucks. Starbucks is using Azure Sphere to connect all of its coffee makers in all of its stores all over the world. It's one of our flagship partners. You might ask why. The Mastrana coffee makers that Starbucks uses actually has recipes that they can send and update in firmware to make a better cup of coffee. And they change those recipes a couple times a year. The way they change them right now is they flash 8,000 USB sticks and send people to stores to change that recipe. Now, that's inefficient, but it also reflects the risk to your business of having something connected to the internet when you don't have confidence in security. Because in this business, if they lost a coffee maker, that's a loss to their brand, and it's also, quite frankly, a huge loss to their revenue. So this is the opportunity, and this opportunity over and over and over again in enterprises going through digital transformation is an opportunity not just to create better customer experiences, but in this case to simply improve on their ROI. Connections to the internet securely with something they have confidence in allows them to, quite frankly, improve margins. So that's the opportunity. So let's talk about the risk. What happens when you connect a device to the internet? Why are we talking about PSA in the last talk? Well, baby monitors spy on you, refrigerators send spam, and cameras launch DDoS attacks and take down portions of the internet. It's embarrassing. I'm sure everyone in this room looks up in the newspaper or somewhere on the internet every other day and sees some sort of attack on some IoT device, and you shake your head and just say, man, isn't that sad? We have to do better. These types of attacks, these types of devices that start to spy on people, it's a loss of trust, quite frankly, from the computing industry. And it's a call to action for a better set of really basics. So the Mirai botnet for the Azure Sphere team was a real turning point for us when we were thinking about the development of this product. You know, we talk about that MCU, that fire and forget device that suddenly becomes a general purpose computer. The Mirai botnet is a fantastic example of it. 100,000 cameras took down the east coast of the internet effectively, catastrophically, 100,000. If you look at appliances that I just talked about earlier, a couple slides ago, there are roughly 300 million appliances sold every year around the world. If you imagine 100 million connected refrigerators decided to launch a denial of service attack. This is just 100,000 devices. Exploited a well-known weakness. It's embarrassing. These cameras had a fixed default password called ROOT. You couldn't change the password, and then once it was discovered that this was the problem, there was no way to remotely update the device. So I don't know how many of you end up acting as IT support for your extended family, but I don't know if you can imagine having people call you and ask you, how do I burn a USB stick to plug into my camera to update it? It's just not something we should think about. But these devices are flowing off into the world with a fire and forget mentality for software, when in reality they're a world where anything that they think that device was built for, it can be used for anything else. The other one that I really like is the hackers attacking a casino. This is a connected thermometer that was put into a fish tank to measure the water temperature, to make sure that those fish stayed alive. Someone bounced an attack through the thermometer onto the network, and they got into the high roller database and stole it. So somebody says to me, well, it's just a thermometer. Why is security important? Isn't my threat model different? Well, no. Your threat model is that if it's connected to the internet, it can be a general purpose computer. And then someone says, well, shouldn't have this casino have known better? Shouldn't they have better network security? Shouldn't they have better ops on site? Shouldn't they be separating their networks into low security and high security devices? And my response is, well, why do they have to do that? It's a casino. Shouldn't they be able to trust that anything that's going to connect to the internet has a basic level of security that's going to protect their assets? I'm going to beat this dead horse one more time. So imagine coming downstairs, and instead of melted ice cream, you have a text on your phone. It says, we own your fridge, send us $5 in Bitcoin, or we melt all the ice cream. That would be a very unhappy family in my household if ransomware took over my refrigerator, my innocuous device. But even worse, the thing that really keeps me up at night is that hackers decide that they know how to turn on the gas and then arbitrarily ignite the stove later. This is actually a real problem that one of a appliance manufacturer ran into, where they realized you could chain an attack into this, and then suddenly your household appliance turns into a bomb. Nobody wants to make these insecure devices. No manufacturer wants to risk their brand. And the question is, okay, well, you know we have these problems. You try to keep hackers out of your device. You're going to follow best practices. But what happens when they do get in? How do you respond to it? Well, the first thing I hear sometimes is, well, our code is better. We follow better practices. We have better processes. We have better engineers. Well, sure, but your product has bugs. This is the NIST security vulnerability causes from 08 to 17. You can see that exponential blue line. That was just buffer overruns. That's one of the oldest known problems in software engineering, is the classic and simple buffer overrun. And there's been a massive spike in reports there. I think that's mainly because we're building better tools to find these bugs. But we're going to keep implementing them. We're going to keep producing software that has bugs. I just don't think as an industry we're there to just claim that we're simply better than that anymore. And if your product has bugs, or you depend on a piece of software or component that has bugs, which your software is only as strong as its weakest component, then that means hackers are going to get in. So security is foundational. It has to be built in from the beginning. You cannot bolt it on afterwards. So this is where Microsoft has come in with Azure Sphere and to start a conversation around IoT security. We published a white paper called The 7 Properties of Highly Secured Devices. And this is a white paper online that you can read. And this is a call to action that says that any device that's going to connect to the open internet should have these 7 properties. If they don't, they should be connected in some other way. You should find some other way to protect or keep these devices off the internet. Without, at minimum, these 7 properties, the risk is just too high. So hardware to trust, defense in depth strategy, a small trusted computing base, dynamic compartments, certificate-based authentication, failure reporting, and renewable security. So I'm going to go through each of these in turn and just give you a little bit of insight about what we mean by this. But please go grab the white paper. Please follow up with Ryan or I or anyone else in the Azure Sphere team. We love having conversations around this. So hardware to trust, an unforgeable cryptographic identity that you can identify the device. Hardware having a private key that is actually private. Public key that allows you to establish an identity. Allows you to bootstrap secure boot. And more importantly, measured boot, which we'll talk about in the 2 talks later today. It also allows you to attest that the device is not just running genuine code, but it's running trusted code, which are actually 2 pretty important and different things. Next, a small trusted computing base. The computing base, I think a lot of people in this room are familiar with this. The software that's most important to your product, the one that has access to your secrets, should be as small as possible. The smaller it is, then the easier it is to reason about its correctness and also and maintain it. So effectively reducing your attack surface. An example, having your security monitor with trust zone or running a hypervisor sitting underneath the kernel. And ideally, your trusted computing base should be measured in kilobytes and not megabytes. Dynamic compartments and defense in depth. Dynamic compartments, as you're familiar with operating systems, we're thinking about MMUs, process-based isolation, allowing to address-based virtualization, as well as defense in depth strategies. The more defense in depth you have, the harder it is for an attacker to chain together a set of attacks. It's simply there to slow someone down and make it more difficult. The fewer defense depth layers you have, the easier it is for once someone finds that attack to get entry to absolutely everything, rather than only one small part of the software that you were shipping. Certificate-based authentication is allowing us to establish an identity for a device, to know who that device is, and to ensure that it's in a good state, and can issue short-lived certificates. So we actually, in Azure Sphere, our attestation service issues certificates effectively as a security token. So the devices don't ship with that device certificate, but we generate that on the fly, and it's only good for a very short period of time, effectively vouching for the fact that Microsoft is attesting to the health of this device. Finally, failure reporting and renewable security. I think of this as closing the loop. When we talk about what happens when an attacker does get in and compromises a system because they found a weakness, then how do you handle and respond to it? Well, failure reporting allows you to gather reports across millions of devices and detect that something has gone wrong. Without that failure reporting, that incoming loop, you're just guessing or waiting for someone to call you, send an email, and let you know that they think something's wrong, or you see a report in the news. And the renewable security, you need the cloud to provide those software updates. You need software to apply the updates, and hardware to prevent rollback attacks. A class of attack where an attacker convinces a device to load a valid but known buggy version of your software. You need hardware to defend against those types of attacks and ensure those rollback attacks cannot happen. So those 7 properties are the properties, as I said, Microsoft is laying down a line to say that if you don't have these 7 properties, you shouldn't allow this device to connect to the internet. You should effectively treat it as a legacy device or a fire and forget device, because you shouldn't count on the fact that it's going to be able to stand up to attacks on the internet. Now, meeting the 7 properties is super challenging. You have to design and build a holistic solution. You only secure is the weakest link. You have to have the technical expertise to stitch these disparate security components together, and make sure you have an end-to-end solution as an OEM or as a device manufacturer that can both respond to threats and update them, as well as ensure the silicon meets these minimum security bars. You also have to be able to recognize and mitigate emerging threats. You have to have security experts available to you to identify these threats, create updates as they're needed to mitigate them, and ship them in a timely manner. And you have to be able to distribute and apply these updates on a global scale. If you have a global product, you have to be able to have the infrastructure, logistics, and operational excellence to ensure you can deliver and deploy updates in your fleet of devices in hours. So Azure Sphere, think of it as a case study, as a product that we're hoping is an example of a product that meets all 7 properties. So Azure Sphere is an end-to-end solution focusing on 3 pillars: Azure Sphere certified chips, this Azure Sphere operating system, and the Azure Sphere security service. I'll touch on each of these briefly. So Azure Sphere certified chips have a hardware-based root of trust that's created by Microsoft but licensed for free to silicon partners. That's based on experiences from securing our own Xbox platform for 3 generations against attackers. The Xbox platform is a great target for an attacker, and there's been a lot of experience built in, and we've derived our own hardware root of trust for IoT based on the experiences and lessons learned there. And a certified chip simply means that this chip meets a minimum set of security requirements that Microsoft has laid out for an IoT connected device. So an example is the MediaTek 3620. It's a template for secure chips. It's our first in-market mass-produced Azure Sphere certified chip. So there's a Cortex-M. This is for real-time processing. This is your typical MCU. Of course, there's connectivity. Any Azure Sphere device is focused on connectivity, so it's being connected to the internet in some way. Then there's the Pluton security subsystem. This is the hardware root of trust that I've been mentioning. Ryan and I will both, in the following talks, be doing a bit of a deep dive and talk about how it's integrated into software and what capabilities it provides in hardware, along with what these are called firewalls, is really features in silicon as a defense in depth measure to, as an example, guarantee that peripherals can only be mapped to certain cores. And then we call it a crossover MCU because it has a Cortex-A. in addition to Cortex-M. That Cortex-A is where we're focused on connectivity. It's where we're running a Linux kernel. And it's where you're having additional headroom, as we talked about earlier, for machine learning and AI algorithms, as well as a minimum of 4 megs of RAM and 16 megs of flash. So there's dev kits now that you can grab if you want to play with one. And we have an ecosystem of partners producing dev kits as well as modules for mass production. So this Magisphere operating system, it's a Defense in Depth OS that's produced by Microsoft and is best of Microsoft and OSS technologies to create a trustworthy experience. So when you look at the OSS, it starts with the Azure Sphere chip. That's a certified chip. Then we have the Pluton runtime. Pluton runtime interacts with the Pluton die or Pluton fabric that initiates all the hard-rooted trust operations. We have a security monitor that runs in Secure World that basically provides and guards access to hardware resources on behalf of the operating system. We have our Linux kernel that runs in Normal World that provides all the services that you'd expect from the Linux kernel, as well as a bunch of changes that we made to improve security. On-chip cloud services, there's services that are basically daemons from Microsoft that focus on update and error reporting that run on the chip. And then we have secure application isolation. These are effectively sandboxes. They allow you to run POSIX apps on top of the Cortex-A, and you can run bare metal RTOSes on the Cortex-M. The Cortex-M relies on basically features in chip to securely isolate that core from the other cores in the chip so they can execute in isolation, provide those real-time guarantees you typically expect from a Cortex-M in that space. And finally, Azure Sphere Security Service. So it brokers trust and detects emerging threats and also upgrades in device security. So it protects the device with certificate-based authentication. Every device in the Azure Sphere ecosystem attests to the Azure Sphere Security Service every day. So if it hasn't attested in the last day, it actually isn't able to connect to any services, whether they're Microsoft or otherwise. And Azure Sphere does work with not only Azure and Azure IoT, but other cloud or on-prem infrastructure. In fact, it's quite simple to grab your certificate chain and then be able to tell whether or not a device has attested to Microsoft successfully before it connects to your own cloud services. It detects emerging threats through these error reports that we talked about. And then it also ships updates. So we ship updates, major updates 4 times a year. We ship bug fixes every month on the Azure Sphere operating system. Customers, as part of this product, can ship application updates whenever they want through our infrastructure, with fully automated on-device updates and hand-free updates and deployments of customers' applications. So the security service is this last and third pillar that sews the Azure Sphere product together. So the other thing that's interesting from our perspective is that this is basically we're really sensitive to the cost of security when we think about a BOM cost for a device. So there's no subscription for Azure Sphere. So there's a license fee that comes as part of the chip. As part of that license fee, you get the operating system, and you get updates as well as the attestation service and error reports for, I believe, 13 years. So we don't want a company to think month to month, am I going to secure this device or not? Do I have to turn security off because this device is 8 years old or 9 years old? And so we decided to eliminate that by having a single cost as a software license with the chip. If you have other services that you want to have in terms of machine learning or telemetry or analytics through Azure, then there is a subscription involved. But for the base service for updates and security, that's simply included. So security is foundational. I have to take away at the start. Evaluate the 7 properties when evaluating security plans. Is the device secure? Does it meet the 7 properties? How is it going to stand up when a device is attacked or is exploited? Check out the white paper on the 7 properties and try out Azure Sphere and give us feedback. We'd love to hear from you. So let's secure the future together. Thank you very much.
So there are 2